All right, so whenever you graph, there's 3 steps. 1, plot the points. 2, draw the line. 3, extend the graph. If you do all this properly, then this part is going to be easy. It's just creating the table of values that's the trickiest. So we're going to plot the points. Over here, notice what your x values are. So we're going to make tick marks that correspond. So here's 0, here's pi over 2, pi, 3 pi over 2, 2 pi, and then it'll keep going, but we're not going to go ahead and write that. And then over here, we're going to have the same like units, but we're going in the negative direction. So this is negative pi over 2, this is negative pi, negative 3 pi over 2, negative 2 pi, and so on. So those are our x values, and here our y values. Notice the only ones we use are 0, 1, and negative 1. So on my y-axis, I'm just going to put 1 here, negative 1 here. And from what we learned about the range of sine and cosine graphs is they're never going to go outside of 1. Okay, the parent functions aren't going to. So now let's just go ahead and plot those points. I'm going to highlight that step in green and then plot my points in green so you can see it really clearly. So here's my first one, 0, 0, and then I've got pi over 2, 1, pi comma 0, 3 pi over 2 comma negative 1, and 2 pi comma 0. See how easy that was? So there's our points. And now that I've got those plotted, I'm going to draw the line. Step 2. So I'm going to attempt to do that in highlighter as well. So if I go over here, draw my line. Now this is a smooth curve. So I don't want to see like connect the dots with straight lines. Okay, this is a smooth curve. And then the last step says to extend the graph. I'm going to do that in pink. So these are our actual values that we found. However, we know because of the periodic property of sine and cosine that this is actually just going to repeat itself over and over and over. So we can extend the graph here and know that it's going to repeat with a similar wave. And then also back here, we can repeat it actually going backwards. Excuse my poor, it's hard without dots, but you can kind of see how it just repeats the same wave over and over and over. And this wave is called oscillating. So down here I'm going to write wave equals oscillating. It's a good word to know that describes what this looks like. So what we just graphed was y equals sine of x. And what you'll notice is if you can actually remember this curve, then you can remember the quadrantal angles of sine. Sine of 0 radians always equals 0. Sine of pi over 2 always equals 1. Sine of pi equals 0. Sine of 3 pi over 2 equals negative 1. And sine of 2 pi equals 0. That's a lot to take in, but that's why having these in your mind is so useful. And never again will you have to sketch out a coordinate grid by hand and do x over r and y over r and all that. So go ahead and glue this in to your ISN. And what I want you to do now is practice by going and doing all these steps, but for cosine, and see what the cosine function looks like. And then tomorrow, I'm not actually going to be there, but I'll leave a key up for you guys to see what cosine looks like, and then you can do some practice with that.